course, the correct answer is C. Yes, 77% got that right. How do we see that? Number of secondary windings, we said is 1,000. Primary is 100. That's a factor of 10. So that goes the same as the voltage factor. So it's 10 times bigger, or 1,200 volts. Now, you sort of pay for that in current, right? The primary, it's equal to the ratio of the primary to secondary current. So the secondary current is a lot smaller, 10 times smaller. So you can step up the voltage, but only at the cost of stepping down the current. Now, we can have a lot of fun with this, with the Tesla coil. I don't know if you've ever heard of these things, but this is sort of doing 2 transformers in a row to make a really high, a very high voltage on the final thing. So how does a Tesla coil work? Well, you start with 120 volts coming out of the wall, and you put it through a transformer. That's a step-up transformer. This electrical symbol just means you have a few windings on this side and many windings on the other side. So this takes it up to, I don't know, perhaps 20,000 volts, something like that, by the fact that it's a 20 to 1 or 200 to 1 ratio of the windings. So now we're putting a alternating very high voltage across this circuit. What does it do? Well, it charges up this capacitor, and when it's high enough voltage, it zaps across this spark gap, meaning it discharges that capacitor suddenly across this primary winding over here on the second transformer. And this one has another step-up factor of a huge amount, taking us up to, I don't know, several 100,000 volts. So if you want to see what several 100,000 volts looks like, you're about to. Because here it is. Here's the Tesla coil. It's not quite as impressive as the one on that on the slide, but not so bad either. Let's see. Move it over more. Turn off the lights. Put on personal protective gear. This thing has a tendency to zap you pretty good. So, turn it on. And what do you see? You see those little streamers coming out the top. That's because that's an open end to the Tesla coil. And the current is just flowing into the air around us. And to prove that, I have this fluorescent light bulb here. All right. Tingly. Anyone who wants to try that after class is welcome. Whew, ozone. So that's what several 100,000 volts looks like. And as I say, the current that's, it's grounded on one side, so it's creating a huge voltage. That current is just arcing through space to the ground. It's such high voltage that it exceeds the breakdown voltage in air, which is a few million volts per centimeter. And so it's huge electric fields are generated at the tip of that thing. I want to build a bigger one that looks like this and do that in class instead. But that's what you can achieve with Tesla coils. They now have these demonstrations. I don't know if you've seen it online. Just put Tesla coil into YouTube. And what they do is they connect the Tesla coil to the music. A lot of them are pretty cool. You got to see it. Okay.